Welcome to The Explainer. Today, we're diving into the hidden climate cost of our cities, and we're going to focus on a place that's transforming at an incredible speed, Vietnam. You know, the buildings we live and work in, they're a massive source of carbon emissions, but there are some brilliant, carbon-smart solutions out there that can change all of that. So, let's dig in.
All right, let's just start with one single staggering number, 39%. That's how much of our total global CO2 emissions comes from the construction sector. It is a huge piece of the climate puzzle, and to even start to solve it, we've got to understand where it all comes from.
Okay, so to really get a handle on this, you have to split that big number into two different problems. This chart breaks it down for us. You can see 18% comes from what we call operational carbon. That's just the energy we use every day. But look at this. Almost as much, 17%, comes from the embodied carbon in the materials and the construction itself.
So on one side, you've got operational carbon, the power for your lights, your air conditioning, all that stuff. And on the other, you have the one we don't talk about nearly enough, embodied carbon. This is all the carbon that's released just to make the materials, ship them to the site, and actually build a building. They're both critical, for sure, but they need totally different solutions.
First up, let's talk operational carbon. This is the energy a building is guzzling every single day, and it's the slightly bigger slice of that emissions pie.
Now, when it comes to cutting these emissions, it's not a free-for-all. There's actually a clear, logical order you need to follow if you want to have the biggest impact. It's not about just, slapping some solar panels on the roof and calling it a day. It's a much smarter, step-by-step process.
And this sequence is absolutely key. You have to start with the fundamentals. Passive design. That means using the building's actual shape and orientation to slash its energy needs from day one. Next, you put in super efficient systems. Then you get smart about when you use energy to avoid those peak high carbon times. And only after you've done all that do you add renewables like solar panels.
Okay, let's switch gears to the other half of this problem, that hidden, upfront carbon cost that's literally locked into the building materials. This is embodied carbon, and this is where the story gets really interesting.
This visual just makes it crystal clear. Look at that. A massive burst of carbon gets released during construction way before anyone even flips on a light switch. That huge spike you see on day one, that's all embodied carbon. It's an upfront climate payment that you can never get back.
And just like with operational carbon, there's a hierarchy, a best way to do things. The most powerful action? It's often the simplest one. Build less. Repurpose the buildings we already have. But if you have to build, then build clever by reusing salvaged materials. And finally, build efficiently. Use things like prefabrication to cut down on waste.
But okay, when we do have to build something new, what are the biggest culprits? I mean, where should we be focusing all our attention?
Well, the data is pretty consistent. No matter how you slice it, a few key materials are doing most of the heavy lifting carbon-wise. Just look at this projection for Europe. The two biggest offenders, by a mile, are concrete and steel.
And believe me, this isn't just a European story. In places that are growing as fast as Vietnam, where new construction is just booming, these two materials, concrete and steel, form the very backbone of new cities. And that means locking in massive amounts of carbon right from the start.
So this brings up a huge question, especially for a place like Vietnam. If you need to build, but you want to avoid those massive locked-in emissions from concrete and steel, what are your alternatives? Well, more and more, the answer is an age-old material with a very modern twist: timber.
Timber is a total game changer, and here's why. First, it replaces those super carbon-intensive materials. But second, and this is the truly incredible part, it actively stores carbon that the trees soaked up from the atmosphere. The building itself literally becomes a carbon sink. And the impact here is massive. We're talking about pilot projects from companies like Microsoft that have shown using mass timber can slash a building's embodied carbon by up to 65% compared to a standard concrete building. That's huge.
And that leads to this mind-blowing idea, a building that's actually net positive, one that stores more carbon that was ever emitted to create it. I mean, just think about that for a second. We could be putting up buildings that are part of the climate solution, not the problem.
But, and this is a really critical point, this amazing carbon benefit completely depends on what happens at the end of the building's life. If that timber just gets burned or tossed in the landfill, all that stored carbon goes right back up into the atmosphere. To actually lock in that climate win, the wood has to be reused or recycled. Planning for how a building comes apart is just as important as planning for how it goes together.
So, with all these options, how can we be sure we're actually making the right choices? How do we really know we're reducing a building's total carbon footprint? How do you compare timber to steel, or a brand new building to a renovation?
Well, the answer is this really powerful tool called a life cycle assessment, or an LCA. Basically, it's a standardized, scientific way to measure the complete environmental impact of a project, from the very beginning to the very end.
And when I say complete life cycle, I mean it. We're talking from cradle to grave, and maybe even beyond. This diagram shows how it accounts for every single stage. You've got the product stage, that's getting the materials. The construction stage, the whole time the building is in use, all the repairs and energy. And finally, the end of life, demolition, disposal, everything. It's a total carbon accounting.
And this just shows you the simple, scientific rigor behind it all. This isn't just some vague idea of being green. The method is the LCA. The specific impact we're measuring is its global warming potential, and we count that impact in a standard unit, kilograms of CO2 equivalent. It turns sustainability from just an opinion into a hard number you can actually work with.
This whole data-driven approach is what lets designers and policymakers compare their options objectively. You can finally make real apples-to-apples comparisons, find the actual carbon hotspots in your project, and make choices that you know will lower emissions, instead of just hoping they do.
So by understanding both the energy our buildings use every day and the carbon that's embodied in their very structure, we can fundamentally change how we build. The knowledge is there, the tools are there, it's not really a technical problem anymore, it's a question of choice. And for countries like Vietnam, at this critical moment of growth, that choice is going to define their skylines for the next 100 years. The story their buildings tell is up to them, and really, it's up to all of us.